The MB8100 test bench for heavy-duty vehicles reveals relentlessly brake calipers that act on one side only or got stuck, as well as untrue and out-of-centre braking discs. Together with the side slip tester, the play detector and the PC visualization, BySpart offers the optimal solution for time and cost-saving vehicle tests, vehicle inspections or safety checks. Installation. Before installing the MB8100 BySpart test lane, check the pit dimensions. If they satisfy the dimensions specified in the planning folder, the roller test bench and the side slip tester can be installed. First of all, the ground plate will be aligned in the pit bed and fixed with dowels. When using the newly developed BySpart assembly frame for this purpose, the fixing dowels are already integrated into the frame. This will further increase the stability and the fit of the plant. After the potentiometer has been connected, it will be attached to the tension spring. The cover plate will slide smoothly and almost unhindered onto the hardened steel balls and running rails. Once the covers have been fixed in their places, the assembly is completed. The next step is the alignment and the installation of the two roller set units. The roller sets will be hanged into steel sleeves that are attached to the support for the weighing unit. This makes it possible to add a weighing device subsequently with relatively little input. After having measured the roller sets, the bearing discs and the elastomer cylinders will be placed into the steel sleeves by observing the correct distances between the individual parts, centered and checked so that their horizontal and vertical alignment is correct. In order to finally fix the steel sleeves, they will be spot welded. The roller sets will then be removed again in order to properly weld the steel sleeves. After having welded the steel sleeves in their final position, the roller sets with their bearing discs and the elastomer cylinders will be lifted back into their correct position. The sensor systems of the two roller sets will be linked with each other in a sensor connection box, and the cables from there will be connected with the relevant plugs in the central control cabinet. The installation pit will eventually be secured with cover plates that are put over the roller sets. The control cabinet with the printer and the PC can now be installed. The electronic and electrical components for all additional functions, such as the pit safety system, the weight simulation system, the PC interface, the radio sensor system MRS 433, a theft alarm, the roller set heating or the matrix printer have all been pre-installed off works. All what needs to be done is mainly to connect the supply lines for the 12 kilowatt motors, including the optional motor brake and the RS 485 transmission to the analog display. It's now possible to install the cabinet with the display. In order to do so, a wall bracket will be mounted on the wall, the base plate will be hung in, and the cabinet with the analog display will be fixed. The latter will be connected with the process control via the RS 485 and thus be ready for operations. The charging unit for the MRS 433 radio sensor system will be mounted on the wall. The 20-bar air pressure sensors or the 200-bar hydraulic sensors will be put into the charging station and secured. Even extremely exhausted sensors can be used for the commissioning after being recharged for just 1 hour. The entire plant will be visually marked as a safety precaution. The software will be installed after the hardware. Depending on the scope of functions required, this will include the STL 9000 PC visualization, the SP Manager, the BNet networking, or the ASA gateway. On turning the main switch on, the components of the test system of the MB8100 will all be subjected to a basic check and started. Operations. In order to start the toe measurement, the truck will be driven over the track plate. The toe in or toe out value thus established will be indicated on the scale of the analog display and on the monitor of the PC station. The vehicle can now be moved into the roller set. In order to carry out an extrapolation, the air pressure sensors will have to be attached to the vehicle's test connectors. The brake efficiency, according to the applied pedal force, can be indicated with the help of the pedal force transmitter. The measurement process will be activated with the remote infrared control so that the rollers start moving. The brake force will be measured and established via a high-precision strain gauge sensor. The data will be transmitted in real time to the analog display and the PC station. The brake force acting on the right and left-hand wheels, the brake pressure and the pedal force will be measured. The process unit will evaluate the brake force difference between the left and right-hand wheel sides. If an axle weight has been entered before the measuring process, the static brake efficiency will be calculated and displayed. If a weighing system is integrated, this work step is dropped and the dynamic brake efficiency will also be displayed in real time. The braking test will be completed when the slip control unit reaches its limit. Following that, this entire procedure will be repeated with each further vehicle axle, irrespective of whether it concerns a truck itself or a trailer. If a parking brake or an emergency brake acts on any of these axles, the relevant results can also be assessed and stored. The MB8100 provides up to 17 different axle tests. In order to carry out an extrapolation, the reference pressure and the total gross weight will have to be entered into the input dialog for the vehicle and customer data. As a final step, the measuring protocol can be printed out via the PC station on any network printer or with a matrix printer of the MB8100 itself.